All right, so we're going to continue on with number 11. We're going to start off, of course, here we need to solve. We see 2x minus 2 equals 3 times x minus 1 minus 5 times 6 minus 2x. So we're going to start off by distributing the 3 inside the x minus 1, and then we're going to distribute the negative 5 inside here. And we have 2x minus 2 equals 3x minus 3 minus 30 plus 10x. Our like terms here, of course, there's a line here, so let's be clear. And the 10x and the 3x are like terms, so that turns to 13x. And then we have the negative 3 and the minus 30 gives us negative 33. And now we need to move all our variables to the left and all of our constants to the right. So we're going to do that by inverse operations. So minus 13x on each side. So this is negative 11x minus 2 equals negative 33. From here, we're going to add 2 to each side. And negative 11x is equal to negative 31 divided by negative 11. And we have x is equal to, that's double negative, so that's positive, 31 over 11, which is A. With number 13, it says solve the following equation for y. This is a literal equation because it has more than one variable. And seeing as how on this left side of the equation we have two terms, we need to get rid of the term without the y in it first. Bring this down so we're left with negative 6y equals, remember 8 minus 2x. 8 doesn't have an x with it, so we cannot subtract it. All we can do is write 8 minus 2x. Divide by negative 6 on each side. And this is y equals negative 4 over 3 plus 1 over 3x. That's our answer. All right, for number 14, this is an inequality. Draw a line down the middle. And remember, the same steps apply to solving inequalities as solving equations, except when we get to the final step, if we have to divide by a negative number, we're going to flip the sign, the inequality. So first step is to distribute. So we get 15 minus 5x is less than negative 2x plus 6. No combining like terms needed. So we're going to put all our variables over here to the left by inverse operation. And we have 15 minus 3x is less than 6. And we're going to move this 15 over here. So this is negative 3x is less than, looks like, that's a negative 9. Divide by negative 3. See how we're dividing by that negative? That tells us we're going to have to write x is greater than negative 9 divided by negative 3 is a positive 3. So that's our answer. Of course, if we want to do some drawing here, we can have an open circle here and we're shading to the right. 15, what value of x makes the equation true? We're going to start off by distributing the negative inside the parentheses here. And then to the right, we're going to distribute the negative 2 inside this parentheses. So we have negative 5x plus 7 plus 4x equals negative 6x plus 8. We do need to combine some like terms, right? A negative 5x, positive 4x, so that's negative x plus 7 equals negative 6x plus 8. Add 6x to each side, and that'll be 5x plus 7 equals 8. Subtract 7, and 5x equals 1. Divide by 5, and x equals 1/5. All right. Now we're moving on to Unit 2. Everything that we just did before was Unit 1, all about equations and inequalities. Now we're going to get into functions. All right. When we look at number 1 here, notice that it says if p of x equals 5 times x squared plus 1 plus 16, what is the value of p of 13? We talked about function notation a little bit on Friday, but basically we see that in the place of x, we now have 13, and so we're going to replace in this equation here, everywhere we see x, we're going to plug in 13. So we write 5 times 13 squared plus 1 plus 16. All right, and now it's just about simplifying this thing. All right, it's just about simplifying. So we get our calculators out and let it be our friend. And what I get out is 866. All right, y'all check me on that. With number 2, it says, which table represents y as a function of x? Keyword function. Remember, functions where x's cannot repeat. If we look here in the first one here, the negative 2's repeat. So that's not it. If we look here, nothing repeats, so perhaps this one is it. Here, the 1's repeat, right? So that's not it. And here, the negative 4's repeat. So that's not it. All right, so it looks like there we are. Number 3, which set of ordered pairs represent y as a function of x? Remembering that x cannot repeat, right? So here, the 1's repeat, so that's not it, right? The 1 here, 1 here. The 8's repeat in B, so that's not it. In number part C, nothing is repeating. I think that's it. And in D, the 4's repeat. So that's not it. My answer is C here. With number 4, it says f of x equals 2 times 1 minus x. What is the value of f of negative 5? Well, that becomes 1 minus our x, which is negative 5. And we're going to simplify it. Listen, the calculator is your friend, so plug it all in, just as I have written it here. Okay? And what we should get out is 12. All right, that's what we should get out. Number 5, which statement describes the mapping to the right? All right. The mapping represents y as a function of x because each y value corresponds to exactly one x value. All right, is that the definition of a function? Well, let's look, guys. Is it a function? It is, because none of these x values are going to 2 or more than one y value. So I think that it's true that y is a function of x. I'm just not sure that the reasoning is correct. But if we look here at G, it says the mapping does not represent a function. Well, we know that's not true because it is a function. J is also not true because it is a function. Let's look at H. It says the mapping represents y as a function of x because each x value corresponds to exactly. Oh, yes, that's the right reasoning. All right, it says, what are the domain and range of f of x equals negative 37? We talked about this on Friday, right? We plugged it in the calculator, saw our nice little graph, and what we would see on a coordinate, right? And we looked at the table to determine this. But what we saw was that the y stays negative 37, so the range has to be negative 37. Which rules out actually all of these answers. And the domain is all real numbers. Because for every value of x, y is negative 37. Number 7. Which table does not show y as a function of x? Which one shows the x repeating? Looks like it's here. The negative 0.2s. So that's H. Number 8. Which representation shows y as a function of x? Which one shows basically where y is not repeating? Well, this is definitely not it. I think this is a mistake. I think that the question is asking which should show y is not a function of x. Because this one shows it, this one shows it, and this one shows it. This is the only one that does not show it. All right. Says, what is the domain of the function for this situation? All right. We see this line here, right, with 2 endpoints. This is a continuous graph. Right? So for the domain, we know we start right down here at 0, goes all the way to 28, right? X is in the middle because we're domain. Endpoints are closed. Whoop, there it is for the domain. The range, well, we start right down here at 0 and then go all the way up here to 9. All right, the endpoints are closed. So there we have it. Right there. Number 10, state, that should say whether each situation is a function or not. The age of students and the number of words they can write per minute. The age of students is going to repeat, so this is not a function. The time spent exercising and the number of calories burnt during that time. The calories burnt does depend on time. And if you walk 2 minutes versus 30, you're going to burn different amounts of calories. So the time is not going to be the same the time is not going to repeat. So this is a function. In a high school, each student's ID number is paired with the student's grade level. Student ID number is independent. It's not going to repeat. So this is a function. If each month is a year, was paired with all possible number of days in the month. If each month in a year was paired with all the possible days. I think that's not a function. Yeah, because the months would repeat. What is the domain of the linear function below? Well, we know we're starting right here at -4 and we're going to 2. This is open, so that's going to be less than. This is closed right here, so that's going to be less than or equal to. Is domain, so we write x. Now, which one of these answers match? Looks like A.